Hello everyone. Today we'll be going through the LiteLLM, how we can use it as a AI engineers, and then yeah, what are the problem it solves. So let's say in the current world, if you are building AI applications, you already know there's a massive headache of API fragmentation because a moment your project touches more than one model, whether for quality, price, or just for fallback, you will maintain a completely different glue for the different provider. You need to write different codes, and then how you call or write the code, right? Calling the LLM. So everything is different. It's hard to manage. So this is exactly the problem Light LLM solves. So it is an open source library that acts as a single switchboard between your code and 100 different LLM models. Because nowadays LLM models, different vendors provides different LLM models and they have different frameworks. So that's the problem that Light LLM solves. So instead of juggling between different SDKs, um request shapes, error formats for every single vendor, LiteLLM lets you write your code exactly once using the standard OpenAI format. It then translates that request on the fly for Anthropic or Gemini or even local modes like Ollama. But it does a lot more than just translate. Today we are going to walk through this visual guide. I will show you how you can use LiteLM to automatically track your call cost, do governance, budgeting, all these things. Let's go to the jump into the session now. Okay, so let's let's talk through this whole uh, guide about LiteLM. So so basically, as I said, in the day-to-day jobs, you will be working on multiple LLMs, right? Multiple models. Sometimes because of the cost, you might need to use Anthropic, like Fable for let's say for harder problems, and then for cheaper ones, you might use different models uh, and all these things, right? As well as how we are going to catch that thing. So, like if multiple same questions are asked multiple times, we don't want to uh, we don't need to reinstate the inference again, and then how to track the cost at the holistic level, either at the personal level or at the project level or at the enterprise level. So how we are going to do that? That's what we are going to see through LiteLM, all the functionalities the LiteLM provides. So if you have app, if we have a LiteLM, either LiteLM can be. So you will see further in the video, saying how we can use LiteLM. LiteLM can be installed in your local, just do a import and then use it, or you will be adding it as a proxy server. So if you do that, you can do everything governance or budgeting layer at the enterprise level as well. Let's dig deep into that now. Yeah, so this is what I was talking about. So so we have same similar OpenAI still for all the provider. And then, like, there are two things. If you are just doing for code, you just do import the SDK of LiteLLM, and then you just import LiteLLM, and you use LiteLLM to basically write your framework where you have a unified framework to call any LLMs. Or if it's for a team, then you will be using a hosting a LiteLLM as a proxy server, and you will be calling it. Yeah, so like if we can even do a load balancing and router if you are using a proxy server, and then for budgeting and catching such things, and then you can even do more things if the context is big on a enterprise level, right? We can basically trim the context based on either semantic matching and different things. the LiteLLM provides. So yeah, in general, what is LiteLLM? LiteLLM is a open source Python library. So it adapts OpenAI-style interface, which helps us to basically use any of the 100 plus LLM providers, but use the similar framework for that. So we don't need to write the whole code from start. So for the easy maintenance. So this is what you will, if you want to have a mental model. So this is what you should have now. What Light LLM actually solves. So instead of writing a application, different code for different models, with Light LLM, everything will get unified into a single platform. So you just use LiteLLM, and then via LiteLLM you call anything. It will be a configurable way of doing things. Yeah, so you're saying how we run Python, LiteLLM? There are two ways. The Python SDK and then the proxy server. So Python SDK is nothing but during your code, anyone just import LiteLLM, this library, and then you like use for the chat completions. You configure the different models. Like we'll see the example code below. Maybe you'll understand that. And then it's a proxy server is nothing but the you basically self-host a LiteLLM server in any of your enterprise servers, and then you call it via HTTP request basically. So all the calls that you are doing, everything goes through this, and then hits any LLMs. So if you want to have a, setup that to be work for the whole team, not just you, then proxy server is the way to go, where we do much more things. Yeah. So um, this is how it will be like you in your company. You might be building a chatbot, or analytics team can be using something, or you build the AI agents on your own with LangGraph or any frameworks. So everything goes through the proxy server, which is LiteLLM, where we manage all the things, and then it goes to the. So the proxy server is the kind of a front-facing tool. Yeah, one thing is here in if you are making it a proxy server, then you need to manage that. Uh, So how we are going to manage that? Like let's say for prompt catching to make sure we reuse the same code, we need to set up the Redis and other Postgres to basically maintain the logs or keys so that we can get the budgets later on, right? By just by querying it. So we need to set this up in our side. Yeah, so this is an example of the Lightel as a SDK. So if you're going to use it in your code, so this is how you use it. So you import LiteLLM. You are going to use a completion proxy, and your environment variable will be like it. We won't be doing it this way. We'll be basically setting it the environment variable, the any Anthropic key, auto key, and then you call the model. This can be again configuration driven, and then we basically pass the context, uh, and then we are going to get the response. Like we call the completion with the model and the message. So it goes hits the model and comes up. So basically, the same completion method will work for any model of any type. So that's handled internally. So we don't need to write a boilerplate code for each of the different models. So going, so yeah, so that's what we are saying for different providers. We just keep the same thing. Response again, it's always same response. So whenever you call a model like this, you see the response. Uh, So for the user query, explain LLM in one line, the assistant gives a single API for 100 plus LLMs. So this is how the response will be. Response is again unified response. So you can parse it you write a single parser which is agnostic for any LLMs. Yeah, this is same thing. Whenever we set the stream to true, right? We don't wait for the entire message to get completed. We just keep streaming the data when the LLM, as soon as LLM generates like few tokens or few words next. Not just this, we can have do more things, more intelligence with this LiteLLM. So yeah, so this will be this can be done once we set up LiteLLM as a proxy. These are like some important things. So what we do is we can get like let's say for each of the requests we are doing, we can get what's the max token required for processing this context. So we get that max token, or once processed we also go know the real time how much token was processed for this request for this user for. So we save keep accumulating into a MySQL. So later on we can get the stats of how much each user has used and what model is getting called, that part of things. And then this is a token counter. So basically like during every context we basically pass through, like we calculate like how much tokens are there in this particular prompt basically that we are sending to the LLM. And then yeah, this is what I was saying before. So once the LLM is actually responded, so based on the input and output tokens we also calculate the completion cost. So how to set this up? So basically in LiteLLM we have these methods: token counter, get max, some completion rate. So we set up token counter. This is to figure out like this is the get max token one. With this we get the get max token and the limit. So basically we will be setting a limit. Basically only this much token we can set. Uh, like let's say at a organization or individual level, we can even set. I'm whenever I'm calling a fable because it's a very powerful model, it's costlier. So we can only send context of this size. So to limit that, so whenever the context grows bigger, we can even do instead of fable, go to some smaller models. The context is big, or either shrink the context and send to fable. So that kind of things we can achieve through this. And then we also make sure like what models we need to support and what not, so that we can do with like support vision. And we have prompt catching, whether we need to enable it or not, because for some of the models it's very much important, like because a fable model are very costlier. To call the same query two times will be like so much costly. So if we have the prompt catching, then we make sure or we are like efficient in our work in the token usage. And then like once the uh, LLM call is happened and we got the streamed output, we can also figure out like what's the total cost, like in terms of token or in terms of USD, we can get everything. So this is about model intelligence, knowing each model's limit and price. So we can set this up. The next one is routing. So how we can do load balancing across deployments. Uh, so what we can do, we can have a set of model groups like open source models or like any cloud hosted models, and then based on different region. So how we need to route, basically the routing strategy is itself a big topic. Like we can do routing, depends on various factors. So here we go through like some of the simple ones as part of this tutorial. So here we basically group the models into different groupings, and we name them. And then whenever something is failed, so which group to call next. So all these precedents we can set it as part of the router. So whenever some model, particularly let's say a model is hosted on Azure East US2, if it keeps failing, then there is some issue, right? Then we have the router rule set up. Then after that, then don't go to any model of this group, then go to the other region, maybe this one. So that's the router. This is one of the use case, which this is the one of the sample that we can do with this. How we can configure this? Let's say this is how we have the mental picture and how basically we are going to do it. So let's see that now. So we have the model name. Uh, so for this model list, we have the list of models where the GPT-4o is hosted in this region and this region. And then what's the routing strategy when this fails? Like how often to call this one, right? So this is like a simple shuffle. Like sometimes it goes here, sometimes it's so we can have different routing strategies added on to this. We don't want to go further into that for this topic. And then how many times you need to retry before going to different model group. Let's say we have different model groups. If it keeps failing, then with this configuration we can just call the completion. So everything is configured as part of router. So we use this router object on top of it. We call the completion, which calls the LLM. Yeah. So these are the high level. What are the different strategies that we can do? This is a simple shuffle one. We can also check based on like what is currently BC, which is not used less. So we can call that more now. And then depending on the usage based, which has more uh, room for tokens processing based on that, and then which has better latency. So for depending on the workload and then the application uh, calling it, we can even point it to different models depending on the latency it provides, and then cost based on which region or which model the cost can be varying as well. Again, this is like fallback and retrace, never return an error. So we can usually write when we call a primary model. Uh, so let's say it can be failing because of multiple things. Sometimes when the model will have, let's say there is a model A, let's say yeah, model A which has a context limit of let's say 500 million or like less like not 500 million, 0.5 million or even 200 million, right? Like 0.2 million, something like that. It's not 500 million, it's like zero point 0.5 or 0.2 or 0.1 million, right? So most models, bigger models will have 1 million context. So let's say we are calling a smaller model with a bigger context, then it will fail because of prompt too long. So if that happens in real time, how we are going to route it? So we need to, the context is big, either we need to shrink the context or route it to a bigger model with 1 million context. So we can do these things here. And then in terms of fallback, if the rate, let's say we have set a rate limit for the users or the user's rate limit exceeded for that particular model, then we need to go for open source model or different groups of model which are less pricier, which are already subscribed by the user. Then we can do that in real time instead of the actual AI pipeline getting failed. We can route it dynamically. And then this is on terms of content, right? Let's say if the request is more secured or like it has some PA information, should not have PA information, not like the content is more risky, which we don't want to call on the some external hosted LLMs. Then for those kinds of content, we can route it to the internal self-hosted LLMs. So yeah, so these are the some of the things we can do to manage the fallbacks and retrace and for the security. So how we are going to do it? So again, it's via the router. We set the fallback logic. What's the model list? And then when something fails, like we can even set it for different error, what model to fall back. But here this is simple. So whenever something is failed, like let's say Fable model fails, then what model to call next? So we can call Sonnet or 4G, 4O. So let's say if Sonnet fails, what to call? So that kind of fallback we can give. Even you can point to some open source model if it fails because of the rate limit or policy fallback. Yeah, so we have again different prompt like general fallbacks. It's like if it is a like context window fallback, what to do. If it's content policy fallback, what to do. We can set for each ones. Yeah, this is one of the important topic where this involves setting up the Redis and MySQL, right? So here, if the users are calling similar or same question multiple times, we don't need to process the same tokens again and again. So this can be uh, actually factored in during the, let's say, the normal Anthropic or cloud models these days have has this prefix. They basically for the same questions of uh, mul- same question we ask multiple times, they are basically handle it their side. They are not going to run it multiple times. Instead, they cost us instead of let's say actual price, they cost lesser price for such questions. So they even won't do the whole inference for these kinds of questions, but we can do this and manage it even better in our own side, because we know the semantic. We not just a direct question to question, right? We can even do the semantics. The wordings can be different, but the semantic is same. So even in that case, if we don't want to call the LLM twice, use the catched answer, then we can go for this way. So yeah, so this is what we are saying. This is the exact match cast. This is very easy. Like if we already match, if the question is already in the Redis, we just check if the same question is there exact match, then just return the answer. Don't need, it's a zero cost. So for this, we need to use Redis uh, or any disk based on like how long the we need to catch these things. Again, depending on the how fast or how fast we need the results. So based on that, we choose the solutioning for this. And then going to semantic catch. So this is for this one, we again need to have a vector DB where we store the matching and then we query it against that. So this involves a bit of costing, but not at the LLM level. So embedding models are quite faster. Yeah, so we need to tweak it anyway better. So yeah, this is to figure out if any similar question within certain similarity threshold, then we can do that. For this one, we can use either Redis semantic or any vector DB like quadrant or any other point cone or anything, depending on our architecture. So so for this one, we get more hit rate because we not only matching on direct exact match, but this will also go wrong. So we need to make sure that threshold is set better, and then the embedding model and is tuned better. So this works better. So basically, a request comes in, it will first check on the exact match because that's a easier one. Then if it is directly matching the exact word, then it just returns with zero cost. If not, the second level is the semantic catch, which uses again it can be any vector DB we query there and then get the semantic match based on the threshold. Again, this is zero cost, just the embedding model calling. Those are like negligible compared to the LLM actual LLM model costs. So how to set this up? So we create a LLM.catch, LiteLLM.catch, and then we see what is the catch and then what's the host URL. So basically, they already have this implemented. We just have to make sure our services are running in the same server as LiteLLM. So it goes to that host, make sure it catch each of the input queries, and then next time it checks against that catched list. This is for the semantic matching and what's the similarity threshold we need to set. So all these things. What's the embedding model again? We need to decide. Yeah, this is what I was saying. The provider already they have their own level of catching. For these ones, they give us at the discounted price. Um, but we can do it even before that. This is like even before calling the provider. So you won't get confused this with the provider level catching. Yeah, next, let's say if you want to we are in an enterprise organization, we need to uh, have a budget. Let's say each user should only use each team or each user level or team level, they only need to use such particular budget within like 1 month or some time frame. Then how to basically configure that. Also, like if it's a budget, instead of failing, we can route to a different models. So how to get all these things set up instead of we don't if we don't want to have any surprise. that but monthly budget came out very much, very bigger than anticipated. Like, so to be in a safer place, we need to do all this. Yes, if a newer Chinese starts using Fable model for all the requests, then price will hit extensively. Then it will be a surprise at the end of the month. So to get rid of all these things, we need to implement such cost trackings and budgets. So how to do this? So as I said, this can be at the team level, or for each team we can set different budgets, and then this can be again at the individual level as well. And then this will be basically um, uh, so how to set this? We can have a kind of a we call this APIs basically to set the best using a master key. We set the budget for each of the model types. So let's say for Fable model we set even lesser type. For other models we can have different budget types, and how we are going to handle it at team level or user level. So we can basically, for this one you can dig deep more into that. This video is mainly for giving you like ideas of what you can do with LiteLLM, so you can, like, when you are actually implementing, you would go deeper into this and then you get more insights and actually implement the production stuff. Next thing is, yeah, this is about the Fable model, right? So I know the context is so big for Fable, the tokens will be very expensive. So how we are going to get rid of that? What's the solution LiteLLM is offering for that? Let's see that. Um, So how we are going to get rid of it? Whenever there is a request coming, calling a Fable model, we check if it is already catched or basically accept a semantic match. The second thing is trimming the tokens. So how we are going to trim the token? We need to figure out a way based on our use case or our domain, right? So if we trim the token, still our price will get reduced, at least for the Fable model. And then this is at the LLM level. They have prompt catch prefix. They also can check that, and then we check whether the budget is still there for that person or for the team. If all goes through, then we call the Fable model. So that's how we implement the thing. So make sure to make sure we won't reach the bigger token costs. So yeah, this is the same thing what I explained. Yeah. So this is how, like, in the code, how to set the trim messages. Like, let's say if the model is Fable, then trim the message to 0.75, and it has its own algorithm to trim it. We can also configure that. So yeah, so we have already completed all the different uh, functionalities the LLM, Light LLM provides. Now think this as a how, kind of a quick glimpse of what we've seen so far. So you can have a good mental picture now. So we can have any applications, either agents or a chatbot or any triggered job in production. It goes to LiteLLM. So LiteLLM takes care of the authentication, budget limits, and then the different catching, semantic and direct catching, and then the routing depending on various things. And then what's a fallback if some model fails, and then the logging the cost. So the bigger picture, either the management team or the uh, budgeting team, you will have the more picture on how it's used, so they can plan the costs, or yeah, they can plan to deploy different models. So that's how this is. So like if we are having it in a just a single YAML file, this is how it looks like. Yeah, we are end of the topic. Yeah, thanks for listening. Hope you have got a very good picture of what the light LLM is. Thanks everyone. Please make sure to subscribe. I'll keep posting such contents which are very deep into tech. Make sure you have the very good picture, and if you want to be stay motivated and keep yourself up to date on the AI stuffs, please subscribe to the channel. Uh, Thanks everyone. Bye.